aware of that, and we will send out a copy of that recording about 72 hours after the event today. So as we've gone through this series of big data events that we've done, we've been excited to see a lot of the perspectives that are brought to this topic. We've seen people who are coming from such a variety of areas and perspectives, trying to find the opportunities that big data offers. For example, improving patient care, optimizing sales activities, and government, for example, responding faster to crises. And I was interested. I was surprised to see an article that I actually in the Washington Post, where they actually talked about the recent U.S. presidential elections and really boiled down the issue to who had used big data most effectively. This was one article here in Washington Post. I believe even CNN had an article similar to this. And so it's amazing the opportunity that people are seeing in big data. And I think that's something that we here at Bodhtree have really tried to revise. I think initially we referred to this kind of as a big data problem, but it really isn't a problem so much as when you traditionally look at that word. Really, it's an opportunity that people see that oftentimes, business can sort of go on without seizing it, but then obviously competitors see that opportunity, and then it can be a problem if you don't seize those opportunities. So anybody looking to run for president in 2016, this is a good place to start. Going to our agenda, we're going to just do a very brief welcome and introduction of our sponsor, Bodhtree. Then we'll have Robert Lancaster, who will talk about the Orbitz big data story. Following that, Kane Sosa will speak about getting started with the big data strategy. And then finally, we're going to answer questions that we have for our panelists. So throughout the presentation, please go into your chat section there and send questions that you have, and we'll have the opportunity to discuss those for about a 10 or 15-minute period at the end. And then finally, at the end, we'll do a drawing like we had mentioned in the promotion for the Kindle Fire HD. Just a quick overview of Bodhtree. Bodhtree has been doing analytic solutions for about a decade. Bodhtree was founded in 1998, and we take our analytic solutions with a laser focus really on solving business problems and achieving business objectives. We don't see analytic solutions as technology for technology's sake. If it's not there to solve a business problem, then it really is not being put to effective use. We mentioned a few of the partners that we have here in the bottom left: IBM, SAP, Oracle, Informatica, Cloudera. And we have globally approximately 850 employees. Here you can see some of our locations globally. Most of our operations we're headquartered here in Fremont, California, which is where I am right now. And then we also have major operations in India. And then a lot of the other offices we have are satellite offices to maintain a close proximity to our customers and improve that level of service. Our services are centered around four main areas: product engineering, analytics, cloud solutions, and enterprise services. And then within these areas, we also have some specific solutions that help customers leverage these technologies better. Those include SecureTree, which is really centralized security for all of your enterprise applications. Additionally, ShareTree is a solution that helps to optimize sales activities. And Teletree provides contextual support for custom applications. And then finally, this slide just emphasizes some of the verticals that Bodhtree serves. And this is not a comprehensive overview, but these are some of the areas where we have some of the biggest focus. Just to introduce our speakers very briefly, Robert Lancaster is a solutions architect at Orbitz. He's also the organizer of the Big Data Meetup Group in Chicago and an organizer of the Chicago Machine Learning Group. And his role at Orbitz is really to provide predictive analysis for Orbitz hotel system. And then following Robert Lancaster, Kane Sosa will be speaking to us. He's the VP of Analytics at Bodhtree. And we highlight some of his professional focus here in high-tech manufacturing, healthcare, retail, and entertainment industries. And we also know some of the passions he has here. And you'll see as Kane speaks, when it comes to visualizing data and making it more accessible to business users is really a big area that he emphasizes.
There we go. Great. So thanks, Ryan. As mentioned, I'm Rob Lancaster. I'm going to talk to you a little bit about the history of Hadoop at Orbitz and about how we're using Hadoop in general and to extend, and specifically to extend our enterprise data warehouse. Already given me a bit of an introduction. I work as a solutions architect and data scientist at Orbitz, where I spend most of my time using our data to make our hotel systems smarter. I'm also an organizer of the Chicago Machine Learning Study Group, and I help to organize the Chicago Big Data Meetup. So if any of you are in Chicago or visiting Chicago and you want to geek out with us, feel free to look us up. A little bit about Orbitz. When most people think about Orbitz, they think about our flagship website, Orbitz.com. But we're actually a collection of websites. Domestically, we have Orbitz and cheaptickets.com. In Europe, we're represented by a family of sites under the eBookers brand. And in Australia, or Oceania in general, India, and all points east, we're represented by Hotel Club and Rates to Go. We also have a corporate travel solutions offering, which provides corporate travel to many companies, including many Fortune 100 companies, and a strong travel distribution arm that makes our product available on other websites. So think, for instance, airlines. We offer our hotel and packaging and car products to sell on airline sites so that they can offer their customers full solutions. So some history about Hadoop at Orbitz. So we didn't actually bring Hadoop in because we had a big data problem. At least, at the time it wasn't a big data problem. We had a particular goal in mind, and this developed into a need to store and analyze data. So this goal was optimizing our hotel sort. The idea being that if we can present at the top of results hotels that users are more interested in, then we can make users happier, we can increase conversion, and make more money. So to do this, a few years ago, we founded the machine learning team with me as the seminal member, with the goal of improving site performance in general, and with our first task being this project to optimize our hotel sort results. To do this, however, we needed data on how users were interacting with the site. So in particular, we needed to know what hotels we presented to users, in which order, what prices were shown, which hotels users clicked on, like maybe they clicked in a picture or they looked at a review for a hotel, which hotels did they select and go to the booking path for, and of course, which hotels did they book. Now the good news is that we're collecting this data in the form of web analytics data. So this is, if you're unfamiliar with web analytics, this is instrumentation that happens in your front end. So it's basically usually takes the form of an invisible image, a 1x1 pixel image on your front end, on the front end of your site, and it captures a query string in the form of key value pairs. And this can have whatever information you want. So it can have information about the page that was displayed and about user behavior. So we were capturing all this in web analytics data, but unfortunately we weren't persisting it very long. The longest archive of the raw data went back about 2 weeks. Now we had a data warehouse, and in this data warehouse we had every transaction that's ever occurred on Orbitz or any of our websites. Any booking, any cancellation, any modification, all that raw detail was available, but this non-transactional data, so hotel searches and hotel clicks and et cetera, was only captured there in an aggregated form. So basically this data would be downloaded nightly, some aggregated metrics would be produced from it, that would be uploaded to the data warehouse, and then after a couple weeks, this data was discarded. Something we would certainly not consider doing today. So we needed a place to store this data, and at first we were using these 1 terabyte drives you might get from Best Buy, but our desks were becoming cluttered, so we needed a long-term solution. Enter Hadoop. So we brought Hadoop in to serve as the storage location and analysis location for this data. And at the time, it was pretty small. I can't remember offhand what the amount is per day, but I mean it's grown much more sizable. But still per day, we were storing a couple months on a 1 terabyte drive, so the amount of data wasn't huge. But we needed a place to analyze it that wasn't going to take a lot of time as well. So then we brought in Hadoop to solve this very problem. And I want to emphasize that this graph is not drawn to scale. Our Hadoop cluster is many more times larger than our current data warehouse. So for the first time, we had data, all the web analytics data, and we were saving it. We were persisting it for perpetually, essentially. Before I go any further, let me give a brief, for those of you who may be unfamiliar with Hadoop, let me give you a brief introduction to what Hadoop is. Hadoop is a distributed file system that enables parallel processing. It was created by Doug Cutting launched by Doug Cutting as an open source Apache project, but is based on work published by Google on the Google file system and MapReduce. It's intended to run on a cluster of so-called commodity hardware. So these are relatively inexpensive machines. The distinction here is that most databases, high-end databases and data warehouses will require either purpose-built or essentially very beefy, very expensive machines, whereas a Hadoop cluster can use more, not necessarily off the shelf, but more off the shelf machines. So for instance, our cluster runs in the same hardware that runs our application stack. So we're talking maybe 8 to 16 cores, which is a lot bigger these days than it was 10 years ago. A decent amount of RAM, but not enough to run a database. But the majority of the machine is spent in storage. So direct drives. And finally, a basic tenet of Hadoop is to bring the processing to the data. So the idea being that the program you're using to analyze your data or to process your data is much smaller than the data size itself. Hadoop exists as more than just this distributed file system and the MapReduce layer on top of it. There's a whole ecosystem that's evolving around it. This is just a small sampling of that ecosystem, but it's some of the things we use here. And so there are members of this ecosystem that I'm more familiar with. So sitting on top of MapReduce are higher level languages, ways to interact with data in Hadoop, like Hive and Pig. Hive provides a SQL-like interface to data in Hadoop. So basically the way it works is you don't create a Hive table and load data into it. You essentially inform Hive about the structure of some underlying data. So you could have data in some sort of delimited form or other structured form like JSON or XML, and you instruct Hive on what this structure is, and then Hive will, armed with this information, will interpret queries that are given to it to build MapReduce jobs to query this data for you. So it's very accessible to people with SQL skills. Pig, on the other hand, Pig is another higher level language. It uses its own syntax called Pig Latin. Being its own syntax, it's not immediately accessible to people without SQL skills, but it has a host more capabilities. So it's a much richer, has a much richer feature set. HBase is a columnar data store that sits on top of HDFS. It uses, although it utilizes HDFS, it also has a large in-memory component, which enables more real-time querying of data in HBase. Zookeeper and Uzi are essentially management systems for Hadoop, and Scoop and Flume are ways to get data in and out of Hadoop. Scoop is generally used to pull data from Hadoop into a relational database, and Flume is really an all-purpose ingestion mechanism. So it can be used to pull log data from logs being generated from real-time applications, or any other kind of data that's being created. So standing up Hadoop allowed us to start doing some pretty cool stuff. So the analysis we're doing on it, for instance, is getting a better idea of the distribution of our hotel searches. So for instance, one thing which is not necessarily startling news, but one of the most popular searches that occur at any time and any day is Las Vegas for arrival this Friday and departure this Sunday. There are a lot of other queries that are very likely to occur, and then there are many queries that are singletons and less likely to occur. This kind of information is driving our the configuration of our hotel rate cache. So if we know which rates have more value, so which are more likely to be requested by somebody else, then we know which we should keep and which we should discard. And it also drives our prefetch behavior. So if we want, we can use this information to pull rates that consumers are most likely going to be asking for in the near future. We have another team that is more interested in the front end behavior of our sites. So using the web analytics data in Hadoop to measure page load times. And so they're able to track page load times of various pages in our site and see how these change as we make changes to production. And our machine learning team is using this data to drive our recommendation module. So they get information on how consumers interact with hotels in which they book, and they use that information to make recommendations to other consumers who are looking at similar hotels. And it drives other analyses as well. So this graph is it's basically the distribution of bookings geographically. This is produced more for fun than anything else, but it also it's color coded to give a representation of the quality of the hotel or the star rating of the hotel. And this is for one of our domestic sites. So we see the U.S. is very popular. Higher quality hotels are booked in Europe. Another developer built an airfare prediction engine. This was first step along the way to get a better understanding of airfares, so we can use the web analytics data to track airfare for the same flight over time, and then began using simple models to try to make predictions about how this airfare will change. And our machine learning team, amongst other analyses, are looking at segmentation analysis. So particularly on how hotel preferences change along various dimensions. The dimension here is the browser being used, and here we see that Safari users are more interested in higher priced, higher quality hotels than their counterparts at using other browsers. Unfortunately, however, Hadoop has been mainly just mainly a playground for developers. So the developers are able to do all these really cool things, but the data is really locked behind a door whose keys are skills such as Java or Python, or the ability to use any other language or use other programming languages that can work well with MapReduce. And even though these higher level languages like Hive and Pig exist, well, Pig has a learning curve because it's a brand new syntax. And Hive, although it offers a SQL interface, still requires the developer to prepare the data to make it Hive friendly and in a format that not less technical users can understand. So the challenge for us has been unlocking the value of all this data that we're now persisting in Hadoop and making it available to our non-technical users. The support from traditional vendors is still a bit meager. There's a lot of companies that are working on it, but it's still on its way. A brief example of some that are working on it: Cloudera, Hortonworks, and MapR are actually distributors for Hadoop. They each have their own Hadoop distribution that they support. Other companies are working on integration with Hadoop. A couple of those listed here. There are 3 main database companies that have partnerships with each of these distributors, And then companies like MicroStrategy and ClickView are working in integration for their reporting tools. And there's some new companies on the horizon as well. Karmosphere offers they offer a tool that is essentially a Hive schema designer and query tool on steroids. So it offers the ability to create tables, create Hive tables, to manipulate Hive tables, and query them, of course. Datamir provides a spreadsheet-like interface on data in Hadoop. So as long as your data is in some sort of format that is well delimited, then they can represent this as they sample it and show a sample in a spreadsheet so that users can manipulate it. So this begins to open up the door even for users without SQL skills. Orbitz, in the meantime, in the last couple of years, we originally started Hadoop as not necessarily a skunked work, but it wasn't an integrated part of our technology. So it was managed by various people on various teams, none of which would have long-term or should have long-term responsibility for Hadoop. So the big data team was formed under the auspices of the business intelligence team to manage the future of Hadoop. And more importantly, by being part of the business intelligence team, they're able to work closely with the data architects on our data warehouse and BI side to begin to leverage Hadoop for our data warehouse. And this move reflects the importance of big data in the future of our company. It essentially became mainstreamed and essential to our business intelligence strategy. So in addition to all the analysis that we're doing on Hadoop, there are two, since we developed the big data team, we've begun working on solutions to integrate Hadoop with our data warehouse. There are two primary ways that we do this now. The first is essentially to use Hadoop to perform the expensive part of the ETL process, so the extraction and transformation part of the ETL process. And the second way that we do it is to offload really heavy analysis from the data warehouse. So think of this like full analysis requiring full table scans, which will not run efficiently on a data warehouse for large tables. So for this, we can bring the data off, essentially offline out of the data warehouse into Hadoop, perform our heavy lifting, and produce our analysis there. I'll walk through a couple of examples of these. First, on the, assuming I can get the page to change. There we go. So the first, I'll walk through the ETL example, and at a very high level, this would look like this. So we start off with raw logs that we would ingest into Hadoop, with the eventual goal of bringing these into a dimensional model in the data warehouse. So we have a particular example where the existing analysis or the existing job looks something like this. So we were producing logs from our web servers. To back up a little bit, this is what we call click data processing, not the most descriptive name. This refers to the data on essentially any click elsewhere in the internet that lands somebody on our site. So this could be links from our meta search partners such as Kayak that are presenting our hotel or air solutions to consumers, and then when they click through, they land somewhere on our site. Or it could be paid search engine placement or natural search engine placement, or ads out in the wild linking to Orbitz. Essentially anything that would bring traffic to Orbitz. We track all these clicks so that we can analyze the effectiveness of all these channels. So this data was logged by web servers and via the ETL process was pushed into the data warehouse nightly. Once it landed there, additional processing was done via a stored procedure until finally the final tables were populated. And after data cleansing, this was roughly 20% of the original data size. And the problem with this is that this took several hours of processing for particularly large values of several. And which meant that during this entire time, this process was eating up load on the data warehouse. And worse, if something should happen to fail in the process, bad piece of data generated some sort of uncaught exception, the process would have to be re-kicked. And when it's re-kicked, it would normally be restarted sometime, maybe around 8 a.m. or 9 a.m. About the time that business users are beginning to use the data warehouse in earnest. So now we have a heavy load job that's hitting the data warehouse at the same time that people are trying to do their jobs. So we moved this process to Hadoop, and so the new process would be, is to gather these web servers into HDFS directly into Hadoop, and then perform the data cleansing step and the transformation step as a MapReduce job in Hadoop, and then load that into the data warehouse. So this process once we did this, the process that once took several hours to complete now completes in about 15 or 20 minutes. So some of the big advantages of this, one, obviously we removed a whole lot of load from the data warehouse. This runs offline, and the data warehouse can be used for what it does best, which is providing real-time access for ad hoc queries and reporting queries. Additionally, since we're persisting this data in Hadoop, prior to this we were processing the data and then throwing away the raw logs. Now we can keep the raw logs in Hadoop because storage is pretty cheap there. And if we ever change anything that we're interested in the data, something that we might have been discarding before, we have that raw data available, so we can bring in additional attributes from that raw data whenever we want. So the advantage of that is that although we would still have to change the schema to import it, we don't just get data from the moment we made the change to the schema. We can repopulate those tables with all the data that we persisted in Hadoop. And finally, allows this process to run more frequently. So instead of just running once a night, since it takes only 15 to 20 minutes to do a day's worth of data, it takes much less than that time to do an hour's worth of data. We can begin processing this data hourly and get a more real-time view of traffic coming to our site. For the analysis example, this is on Geo-Targeting ads. So you may be familiar with these. Essentially, when a user visits our site and they do something on our site, like they do a search for, say, Las Vegas or Chicago or what have you, and then they haven't booked yet, they haven't made the decision, but they go out, go off in the wild on the internet somewhere, and they happen to land on a page that for which we bought an ad spot, or we've made a bid and can give or we can bid to get an ad spot. We want to show that user an ad that's relevant to what they're looking for in travel, so this is essentially the goal of this project. So prior to Hadoop, our marketing teams were able to, our marketing technology teams were able to run this job on the data warehouse, but for less than a month's worth of data, which wasn't giving them a lot of predictive value. By moving this to Hadoop, they were able to process more than a year's worth of data, which was essentially the full gamut of data that was available at the time. This is now over 2 years that they're processing on a regular basis. And it obviously provided analysis that was difficult or impossible to perform in the data warehouse. And this highlights, it's not necessarily a problem with databases and data warehouses, but something they're not necessarily designed to do well, and that's a full table scan. When you create or really a change in use cases, when you a severe change in use cases, we were originally collecting this data more for reporting purposes, not for analysis purposes. And when you create a database schema, you generally have to have your use cases in mind. So your indexing strategy and your table structures are built with your original use cases in mind. As those use cases change, your schema may no longer be optimal for those new use cases, and this is one of those examples. In particular, we were doing this since we were trying to use all the data. This required a full table scan to some exceptionally large tables, which, regardless of your indexing strategy, it's not going to work. Not going to work well in most databases. But Hadoop is full scan friendly, and so this performed very well there. And conclusion. So, other than the last two examples, we found Hadoop to be a very good complement to the data warehouse, particularly in the areas of ETL and off-work analysis. In general, however, the Hadoop environment is still pretty immature, but a lot of vendors are working on integration with their solutions. And if you're looking for such, keep in mind that there's some new startups who are doing some really cool things that might be offering solutions that can fit your needs. We don't think Hadoop's going to replace your data warehouse anytime soon, but if you've got a particularly large data warehouse and are interested in doing more with your data, you should be looking at Hadoop. And if you do bring Hadoop in, work closely with your data management teams. Your idea of what big data is and their idea of what big data is not necessarily going to be the same, but you can work together to discover how Hadoop can really help to offload some of the heavy lifting from your data warehouse. Thanks. With that, I'll turn it back over to Ryan.
Hey, thank you, Robert. That was excellent. Let me go ahead. We're going to turn the time over here to Kane. And we will want to get to questions. Please do continue everybody to submit your questions. We'll get to questions at about about 10 minutes before the hour, a little bit after that. But do continue to present those and share those with us. Kane, now you have control. Are you there? Or can you do a mic check?
Yeah, can you guys hear me?
Yes.
Perfect. So welcome everyone. My name is Kane Sosa, and I want to thank everyone for attending. I'm very excited today to talk to you today about how Bodhtree is helping different organizations in different industries leveraging big data technologies. Today I'll focus on how to get started and what does that strategy look like. The buzzword of the day is big data. The explosion of information whose potential uses have barely begun to be explored. Organizations want to understand how they can benefit from it. Everyone knows it's coming, but are we prepared for it? Are we taking the necessary steps to understand it, process it, and leverage it to gain the new insights? The big picture of big data, 90% of the data in the world was created in the last 2 years. 2.5 quintillion bytes of data is created every day. And of that data, 80% of it is unstructured. The big data market is booming. We see about 90% of the Fortune 500 companies will at least have one big data initiative underway by the end of 2012. And 94% of the big data users will perform analytics on large volumes of data, not possible before. Sorry, I think there's a slight lag in my presentation. Sorry about that. The market will continue to grow. We're right now, by the end of 2012, at 5 billion this year, but the increase in the next 5 years is going to be by 57%. So I'm very passionate about visualizing ideas. So I took a stab at mind mapping the big data universe. As you can see, there's a lot of choices and paths. We see our typical players in BI, such as Business Objects and MicroStrategy. We even see the big players now introducing their big data initiatives or platforms under HANA or QData. In advanced analytics, we see SAP and SPSS, and new players such as QuickBooks and Revolution R doing some great innovations. As things progress, visualizing data has brought us even closer to being more interactive with the data and interacting it very differently. And now we see Tableau and QlikView. And as you run through it, we can see the infrastructure as well. We see Cloudera and NetBar doing some great stuff. And we see Informatica and Pervasive really understanding the infrastructure and the integration of a lot of this data. There's some great technologies out there. Robert spoke about Hadoop and some great projects. Everybody understands about Cassandra and Hive. So it's very important when you're going through this big data universe to partner with companies like Bodhtree to help you navigate, to help you understand what are the next steps. Sorry, there is a lag in my, so the big data opportunities, where to look and where to start. Obviously, there's a lot of buzzwords out there. So before you start a big data implementation or proof of concept for big data, you want to start to understand what is that strategy and how to successfully accomplish your objectives. Within the strategy, we have 3 assessment paths that you can take. They consist of the following. It's the business, the solution, and the data. Within the business, you need to understand the business needs and the objectives to define the big data and what it can offer for your organization. For solutions, you review the current architecture, the technologies, and the infrastructure to define the plan for big data capability that will suit your business needs. And last, very importantly, is the data path. In that assessment, you audit the information both internally and externally to define what set of information is relevant to address your issues. And I'll go into the next detail. Within that, you have access, analyze, and design. And the first component is you look at the opportunity to go and talk to your business, to understand what their vision is. What is the top drivers for that business? Then you talk to IT. You talk and you understand that technology landscape. What are their challenges? You understand where the information is being audited. Next, everybody see, Ryan, can you guys? I think there's definitely a lag.
1 second here, Ken. Let me see if I can fix that. See what might be causing that. Okay.
There's almost like a 30-second delay when I see it and when it's.
Okay.
It's fine.
Let me just bring up the rest of that slide for you.
Yeah, it's fine.
I'll just go ahead and control it there. Ken, go ahead. Just tell me when you need to go to the next slide. Thank you.
Okay, I think that'll be better. Thanks. So let me just ask you. There's 3 paths: access, analyze, design, and recommend. And within that, there are 3 paths, which I mentioned earlier: the business, the solution, and data. After you understand the vision and the strategy and what the top drivers are and the needs and those challenges, you then start having a conversation with IT, and you start understanding what that landscape looks like. What is that current architecture? What is the technology? What is the infrastructure that's supporting the current environment? After that, you go and you access the current information sources. Where's all that data coming from, and how is it flowing through the organization? And then at that time, you're able to audit that, both internally and externally. There's a lot of opportunities in the information you already have inside. More importantly, you also want to go and see what information is outside, such as the social graph and other outside sources as well. Then you go into analyze and design. You identify some of those opportunities and those quick wins that's going to help you with big data. And then you're going to be able to understand what is capture those big data capabilities for your business and evaluate the technologies that are going to be able to get you there. The last but not least is the ability for you to go and understand what's the recommended path. What can you solve short-term, mid-term, and long-term? What is going to be the new insights that's going to come from this process? And now you have an executable roadmap and a blueprint for your solution. Can we go to the next slide? The following represents part of that outcome. It's an executive view of how big data can enable your organization. So as I went through the methodology before, this is the actual outcome that you have. Within your organization, you'll basically have an opportunity to understand what your current environment is. Can you go to the next slide? There's different issues that sprinkle in various areas. So I'll give you an example. Can you do one more slide? There we go. The inability for the business to leverage existing data to provide additional insights. Or maybe the business wants to make more sophisticated analysis on the new data. One more. Actually, just go to the third one. Yeah, there we go. And then you start understanding also that within the infrastructure, the data integration, you need to improve the performance on how that data is moving through the organization. Or maybe your current technology is in your organization is incapable to handle large volumes of data or variety of different types of data. And the last part, which is very important, this is just an example, is missing data elements, such as structured and semi-structured. Can you go to the next slide? So I'm not going to cover all the details, but when you go into and understand what the current state is, you have a few other sections. You do have the ability, as I just described, some of those issues. You basically start articulating those issues by priority, both for the business and technology. And then you are able to articulate that in the left panel. Okay, next slide. Then once you start understanding what those issues are, you start looking for what those recommendations are. How can you solve those in short term, mid-term, or long term? And that's different for every organization. Short term sometimes can mean really quickly, in maybe a few weeks, and a mid-term can mean something within less than 6 months, and then long term. But that all depends on how you want to execute this and how fast you want to solve some of those quick wins and that low-hanging fruit. The conclusion is, for organizations to put their business in the path of analytic success, you need, in both terms for business and IT, there's an explosion of information that has really begun to be explored. So organizations really want to understand how they can benefit from those and gain new insights. So the solution is to develop an executable plan that will guide you to organizational success, a single playbook for the entire enterprise. The results can be actually in weeks, or it can be in 90 days. There's both qualitative and quantity results associated. But you will get an executable roadmap. You'll get a blueprint blueprint for your solution. Or if you want to start a proof of concept, this is a very good example of going through that strategy, that assessment, and running through that process and having the ability to start that proof of concept with a use case. Last but not least, we will be having ShareTree is one of our key solutions at Bodhtree that addresses some of the challenges in the big data ecosystem. We're going to be talking a little bit that further in our next webinar in January. But the following slide represents a quick use case for sales and marketing. It applies to other functional groups as well. ShareTree can illustrate the value of data, both structured and unstructured. And it's important that it leverages the value of data, not necessarily the footprint of the system. You have the opportunity to mash up the who, the what, and the why. And this is extremely important where other customers in the past have understood the who the customer is, or who that patient is, or who that partner is. And in the past, people have understood also what they're selling, what that product looks like, what that service are offering. But now you have the opportunity to understand why you're selling it. And that's what ShareTree enables you. But we'll be talking a little bit much more in detail in our webinar in January. And I think that's it.
Excellent. Hey, thank you, Kane.
Yeah, sorry about that. There is definitely a glitch from the process, but hopefully everybody had an opportunity to follow that.
And we will be sharing these slides that you'll have a chance to go through, and we'll provide that in the follow-up email, and so you'll be able to get through a little bit more. But yeah, Kane was right. There was kind of a delay, and I don't know. We'll figure that out for the next webinar. Thank you both to Kane and Robert for your insights. I think this really does give a lot of direction. I think big data really is a topic that that there's a certain amount of ambiguity surrounding it, and a certain amount of buzz that sometimes to pierce that, to get through to the real value of it is a difficult thing for organizations when they're starting off. A couple of the questions that we had, let me ask this first question to, this was just a question I think for Robert. Somebody had asked, can you estimate the hardware costs for your Hadoop hardware installation? I don't know if that's something that you feel comfortable doing, but if you're not able to give anything specific, just kind of give an idea, maybe some comparisons about what that cost is, because I know that's one of the big value opportunities with Hadoop is that it is more cost effective.
Yeah, I don't remember the specifics. I think that our standard node cost is something like $5,000 or $6,000. Maybe a little bit more. We're moving to higher RAM and higher storage, which will increase the cost a little bit. But $5,000 or $6,000 is, I think, roughly about where it is right now. Maybe up to $8,000 as we get higher RAM and stuff.
Excellent. Thank you.
Storage-wise, I can't remember what we're getting for that cost. But it's, I think it's going to be certainly a few terabytes on each node for that cost.
Let me actually do one other follow-up for Robert. You obviously were moving into the big data space pretty early on, and wanted to get a sense of how you secured the executive support and what type of timeline did they give you to produce ROI, and just wondering how you got that initiative moving forward, really.
Okay. Well, so it kind of helped that we had executives who are very interested in data-driven approaches. Our CEO in particular is really a proponent on harnessing the power of data. So it wasn't hard to convince our leadership to let us try this out. And we'd started this particular goal of hotel floor optimization and needed a solution for it. Our solution to store the data required for it. So it was not, for us, it wasn't a hard sell at all. It was really encouraged for us to begin doing that. But showing ROI was a little more difficult because we chose as our first problem something that's particularly hard. But once we had Hadoop in the door, we really opened up. It really opened up for many other teams to begin using it. So the web analytics data was now persisted for the first time ever for longer than 2 weeks, and it opened up a score of different use cases that started showing value pretty immediately.
Excellent. A question for Kane. Kane, when an organization or an enterprise looks to start on this path, this big data path, obviously one of the big questions is do they go to their internal resources or do they look externally? What's your advice? What's the right balance with training internal resources to manage these initiatives internally, or bring in specialized expertise in the form of a vendor?
It depends. It depends on the organization, and it depends on the skill sets. For instance, for Robert, he has buy-in for the top-down, correct? And then there was also some not only some interest to basically to leverage the data and maybe start using new technologies, but more importantly, the skill set to continue that. So if within your organization you need to understand maybe a use case or a business case to figure that out, sometimes it's difficult for you to apply that and for people to actually have an executive buy-in to start with. So at that time, maybe you would probably have a partner, have somebody to help you that understands the landscape really well, and be able to tell you what it really means. There's a lot of buzz and trends and a lot of noise out there, so you really need to understand what are the right technologies and the right solutions that's going to help the organization, not just the buzzwords, correct? You don't need to make a big investment. The whole point of big data technology now is the opportunity to do this cost effectively and to do this quick. So that's very important. So just find a partner, basically to answer your question. Find a partner, or if you already have that expertise, articulate it, and basically, just like I mentioned a little bit earlier, just find the right strategy in that path to access where you're at and where you want to go.
Excellent. So it looks like we're coming up on the end of the hour here, and just let me give a couple of announcements, then we'll do our drawing that we had talked about earlier. First of all, we will provide the link to the webinar within about 72 hours, and at that time, in that email, we'll give a landing page where you can access the PowerPoints and get a chance to, kind of have the opportunity, I think, to share that with some colleagues that may not have been able to make it to this event. Also, just some of the upcoming things that we have. In December, our marketing team is going to just send an email out just requesting some feedback, and we'll also provide a coupon for Starbucks coffee. So kind of coffee and feedback, really that's focused on making sure that our events are relevant to your needs, to your organization, your role. We want to improve that as we go through into 2013 so we can continue this relationship with our community. Next,
Ryan?
I'm sorry?
Ryan.
Yes, go ahead, King.
Ryan, really quick. Hey, as part of that feedback for that coffee break, if you guys saw that mind map of the big data universe, is actually interactive, so you're going to be able to see a lot of the information when you cover it. That will also be part of one of the things that you guys are going to do a download if you participate in that feedback. I just wanted to add that.
Excellent. Thank you, Kane. And then also, Kane had alluded to this in January. We'll do our next webinar. That'll be on January 23rd, and we'll send out some information there at the start of the new year. Finally, if you have any specific questions, I believe we had one question we weren't able to get to, so I'll go ahead and address that separately, and we'll give you a call and touch base with you. But if you have any other questions that are specific to your organization, drop a note to my email if you'd like to, and we also have given you Kane's email there. And so I have that information here. Please feel free to give a call or drop an email. Finally, with our drawing for the Kindle Fire HD, the winner that we drew was Maribeth Quinn from Nationwide Children's Hospital. Again, it was Maribeth Quinn from Nationwide Children's Hospital. I can hear her cheering through the mute button there. So we'll go ahead and touch base with Meredith just after the call there. And again, we appreciate everybody's attendance. We look forward to continuing the conversation. And I believe if you have any questions, Twitter also is a great format for that. We'll continue the conversation there for at least an hour after the webinar. Thank you so much, and have a great day.